In this part, I'm going to look at the use of a meta class to help with the kind of the management of classes in a larger program. To do that, I want to focus on this table printing code that we wrote earlier in the course. Just to refresh your memory on that, we made this file table. And the way that we used that is that file had these different formatting classes. So you could say table, text table formatter, for instance. And then it had this print table function where you could feed it a list of objects along with some attributes and a formatter. And then what it would do is make some output. So the code above, again, we had like a table formatter base class here. And then we had different classes under that. We had a text table formatter, and we had CSV table formatter, and HTML table formatter, and so forth. So the idea is that somebody could pick their formatting class and then use that to make output in different ways. Now, one of the problems with doing this, here's a practical situation that arises. Let's say you have a lot of these different table formatter classes sitting around. CSV, HTML, plain text, Excel, and so forth. It becomes a little bit of a burden on the user to remember where those classes are and what they're called. Like they have long names. They might actually be split across multiple files. It can be hard to kind of manage that. One of the things that somebody might do is they would write like a little factory function or something. They would say, well, I'm going to make a little function create formatter where you give me a name. And then what I do is I associate kind of a short name with like the actual class. So I might do something like this. You can already maybe start to see a problem with this. So what I'm doing here is I'm writing like a function where you give me like a short name. It picks the class that you're going to use. And then maybe I return that back. I'll raise an error maybe. If you give me a bad name. Let's say you had something like that. First of all, the whole idea on doing that is that if somebody wanted to make a formatter, what they would do is they would say formatter is equal to table create formatter text, for instance, just using that one function, and then maybe use that to make the formatter object. They're trying to simplify the process of making these formatters. When you do that, this sort of code turns out to be kind of unmaintainable, or at least not easily maintainable, because if somebody starts adding new classes to that, they're going to have to change this create formatter function. Like if somebody added a completely new class that does formatting, they're going to have to change the code to do that, and it's just not cool. I mean, it's got to be a better way to do that. One of the things that somebody might do is they might say, well, I'll make a dictionary, for instance. Maybe I have a dictionary of formatters. You put in your formats like this. Okay, so make a dictionary. Has the formatters in there. And then what I could do is modify the code to pull it out of that dictionary. I could say, well, the formatter is equal to formatters get name, for instance. If there's nothing there, I'll raise an error and then otherwise return it back. I'm going to make a slight change to this just to make it easier. This is actually going to create an instance by doing that. I thought that was a little weird at the bottom having to do it like that. So somebody might modify the code to pull things out of a dictionary. That would at least solve the problem of having that nasty if statement. So I managed to get rid of that. But then what ends up happening is you have this problem of managing this formatters dictionary. There's this question of, how do I get things into the dictionary? So the writer of this code, you might start thinking about different ways of doing this. Maybe a different way of doing this would be to have like a formatters dictionary here. And then maybe I have like a register formatter function where you give me the name and then the class. And then what that would do is add the class to a dictionary. And then what you would do is after you defined each class, you would call that, like you would say register formatter text table formatter. You'd have to do this for every single class. So like the CSV would be the CSV table formatter and so forth. What's actually happening here is you're building up a lot of sort of machinery just related to the management of these classes. The end user of this doesn't even really care about this, but you're essentially facing a lot of code where you're just doing bookkeeping. You're just trying to keep track of classes and provide some way for them to register themselves with this table module in some way. Let's just make sure that this still works. So you would say a formatter is equal to table create formatter, HTML, like that. And then I should be able to say table, print table, portfolio, name shares, formatter. Okay. Code still works, but got a lot more complexity kind of going on in this table file at this point. Now, one of the things that you could do to clean this up, it's a little messy. I mean, we have these classes, but we have this extra registration step. This can get really ugly once this starts to spread out across multiple program modules. Like you might have different files, different modules, different extensions. You're trying to pull all of this information together. It turns out that this sort of thing can actually be solved by the use of a meta class. And you say, well, how can you do that? Well, one of the ways that you can do it is I'm going to make, like, I guess I'll call a class, I'll call it table meta. I'm going to make a class table meta here that inherits from type. So I get the class name, I get the bases, and I get the method. I'm going to go ahead and, okay, so we're going to make a class. Then what I'm going to do is I'm going to look at the resulting class and just see whether it has like a name attribute. And if it does, what I'm going to do is I'm going to register it with like this formats dictionary. So I'm going to have this little dictionary of formatters here. So I'll say formatters class name is equal to class. Essentially what I'm doing is kind of looking at the class that got created, and I'm going to auto register it with this formatters dictionary. I'll put the dictionary up here. Okay, so keep in mind, what I'm doing is I'm injecting like a little tiny bit of extra processing into the type creation here. This init method, by the way, is something that gets called when a class has already been created, it's already set up. It's initialized, so it should have all of the attributes on there. And then what I'm going to do is I'll make this table formatter base class use that. I'm going to say that the meta class of table formatter is this table meta. Then what I'm going to do is instead of having this register function and that dictionary, I'm going to make each class just set a name. I'll say the name of that is text. We get rid of register formatter. The name of this is CSV. Get rid of that. The name of this is HTML. I get rid of all of this like registration stuff. And it turns out that by doing that, you'll find that these classes will like automatically register themselves with that formatters dictionary. Like if I look at the contents, you will see that it's like already populated with these classes. If I were to make a new class, like if I were to say class my formatter inherits from table, table formatter, and I just made up some new format, maybe a format of, spam or something like that. If I were to look at the formatters, you would see that all of a sudden show up in there. It's magic. It's just the mere act of inheriting from table format allows you to kind of register your class with that function. So we can now use that to make, like a formatter object, text, and then use that to print a table out. So that's kind of one use of meta classes, is to do that sort of thing. I mean, basically supervise, a collection of classes. One thing that I do have to warn you about is that using meta classes can be a very tricky affair if you have more than one thing going on. One thing that was a little bit tricky about this is that I was using this concept of an abstract base class before. It turns out that that feature of Python also uses a meta class to make it work. And technically speaking, if I wanted to keep using that feature, I would have to use that with my code as well. I would have to modify my meta class to inherit from ABC meta instead. That is a technical detail. I would say don't worry about it too much right now, but know that if you start messing around with this, there are some tricky corner cases. So that's one use of meta classes, basically trying to supervise a collection of classes and kind of manage how they kind of come together there.